Hey everyone, I'm Denise Gosnell, and this is Projecting Traversals. When we are building gremlin queries, I like to think of this process loosely in my head as the reverse of the traditional select from where. To me, projecting traversals are a way that you can where, from, and select. It gives you the ability to do those select statements and pick the data you want to see at that point in your query. So a bit more concretely, a projecting traversal are those steps which use your previously labeled traversers in your query and bring them forward to be used again. Projecting traversals generate new traversers that correspond to the previously labeled steps. A projecting traversal can also be simple, branching, recursive, path, and so on. So let's visualize this. In this diagram, we can see 6 total states for our traversers: a start, a finish, and 4 traverser states in between. The small colored triangles above the gremlins at the start and step 3 represent labeled steps. We can imagine that the step at the finish was a projecting step, which specifically asked to bring forward the traversers from the start and step 3. We see this as the marked gremlins are visually duplicated and brought forward to the right after the finishing step. In the gremlin language, we have 2 examples of projecting traversals. The most common one we use is the select step. The select step is used to grab a previously labeled traversal to make use of it later on. Its parameters are step labels that are previously defined in the query using the step modulator as. The next step to talk about is where. There are multiple ways to use the step where in the gremlin language, but the use that is most like a projecting step is when we use where to recall a previous step and evaluate some predicate on those traversers. Where does not return or project new traversers, but instead it can refer to previously labeled steps to evaluate some condition. We are going to use both select and where in some examples coming up, and the difference between them will be much more clear. There are 2 step modulators that are frequently used with projecting traversals: as and by. The as step is the way to label a part of your gremlin query. This is the must-have step with a projecting traversal. We have to label something with as in order to use it again later in the query. In practice, we use the as step to assign a meaningful name to a part of a traversal. Then that can be used later on. By is also very useful to use with projecting traversals. It is similar to saying that we now have some object and we want to use it in a particular way. The by step modulator is frequently used in projecting traversals to specify what to project, such as a specific element, property value, ID, or even another internal traversal as a result. Both the as and by step modulators are not specific to projecting traversals, and they can be used with many other steps in other traversals. But we're going to walk through some examples that show how to use them for projecting traversals. As a reminder, as always, this is our killer video graph schema. Movies are related to people. Movies belong to genres. There are people who have acted, directed, composed, and other types of activities with the movies. Users rate movies, and users know other users. So let's dig in and go through an example. Let's say, for an example, that we want to find the movies that Johnny Depp has acted in, and we want to create a specific payload that has the keys actor and movie. To do that, remember that we're loosely going in reverse from traditional querying. Here, we want to follow the loose traversal pattern of where, from, and then select. To do this, we start by finding where our gremlin traverser is going to start their journey, the Johnny Depp person vertex, and that's the first query you see. Once we found where we are starting, let's give this step a name by using the as step. Here, we're labeling the Johnny Depp person vertex as actor. From our starting point, we need to get to the movie vertices by walking through the edge, pointing into the actor vertex. Let's label this step as movie. Lastly, we want to select some data to be returned from our query. Specifically, we want to select the actor Johnny Depp and the movies he has acted in. And we want to build up a view of that data, so we use the by modulators. You will need to write as many by modulators as items you are selecting. The first by modulator is going to apply to the first item that you're selecting. So as you can see here, we want to select the actor vertex by their name. Next, the second by modulator is going to apply to the second object that we're selecting in the select step, which is the movie. We can select any property from the movie vertex in the by modulator, but here we just wanted to look at the movie's title. And finally, let's take a look at one of the results, and you can see here that we have the key actor with the value Johnny Depp and the key movie with Alice in Wonderland. In this next example, maybe our application needs more than just the actor's name and the movie title. So in this example, we're going to add in the year and the genre. To do that, remember that we're loosely going in reverse from traditional querying. Here, we want to follow that general traversal pattern of where, from, and then select. Let's start with the where. We need to identify where our traversals are going to start and where they're going to then walk through the graph. As before, we query for the Johnny Depp person vertex and label it A with the as step. From this starting point, we need to walk to movies and genres to get access to the remaining 3 elements for our payload. We walk through the in-edge actor to get to the movie vertices. We know the movie vertices have the title and year for the film, so we give these vertices 2 labels, T for title and Y for year. From the movie vertices, we walk over to the genre vertices using the belongs to edge. Let's label this with a G for genre. Lastly, we need to use the projecting step, select, to access our labeled data. Remember, for each item we select, we also need to provide a by modulator to indicate exactly which piece of data we want to put into our payload. So as you see here, the A was for actor, and we want to select the actor by their name. T and Y were on the movie vertices, so we want to select the title and the year. Lastly, for G, the genre, we want to select the genre's name. Let's sample 2 of those and take a look at the data. You can see we found Johnny Depp from the movie Into the Woods, which was labeled as a comedy from 2014, and it was also labeled as a fantasy from 2014. One last example of the where from select pattern. In this final example of a projecting traversal, we're going to again find Johnny Depp's movies with their title and year, but this time we're going to add in calculating their average ratings. So we're going to start off as we did before. We're going to find the Johnny Depp person vertex and label it with an A for actor. Next, we're going to go to the movies, Johnny Depp's movies, and we're going to label that set of vertices with T, Y, and R for title, year, and rating. This time, we're going to select the actors and the movie vertices, but we're going to add in a traversal in the by modulator. The first 3 by modulators are the same as before. We're selecting the actor by their name, the movie by its title, and then the movie again by its year. And lastly, we need to find the ratings or the average ratings for each of these movies. And for that by modulator, we're going to do a traversal. From the movie vertex, we need to go through the edge rated, which is an in edge. And on that edge, we need to get access to the rating values by saying values rating. And then we would like to compute the mean. We're going to sample 1 and take a look at the results. We find Johnny Depp, Alice in Wonderland from the year 2010 with an average rating of 6 from our users in Killer Video. The last 3 examples have demonstrated how we use as, select, and by in projecting traversals. Next, let's bring the step where into our query as a filter. In this example, we want to find directors who appeared in their own movies. In this traversal, we want to start with our person vertices, but we only want to start with those people who both directed and acted in the same movie. Now, this query is going to have to be run in OLAP mode because it requires analyzing a full partition of vertices, namely the person vertices. Regardless, to do this, we want to start by labeling all person vertices as D, which will eventually be used for director. But starting from here, we have all persons, not just directors. So with this data model, we have to walk out to the movie vertex through the director edge to filter out all persons who are not directors. We eventually will need data from the movie vertex, so while we're here, let's label this step with T and Y as before, since we know we're going to need the title and year from the movie vertex later on. Next, we will walk back to the person vertices through the actor edge and label these traversals as A for actor. Now here's the trick. We want to select the persons from the first step and only select those traversals who are labeled D and only let those traversals live on if their corresponding actor is the same. We do this by selecting D and apply a filter with the where statement. Specifically, we allow all D persons to pass our filter only if they are the same person as the actor A. In other words, if we have a director who is also an actor in the movie, we would like those traversals to pass through this filter. The next select builds up the payload we want with the remaining values from the traversal, the directors, movie title, and the year of the movie. And hopefully this was one of the examples you imagined that you would come up with, Quentin Tarantino from Pulp Fiction in 1994. Let's do one last example here to show you yet another way to use the select where pattern. We're going to stick with the same concept. We want to find the directors who appeared in their own movies. But this time, let's make use of a different form of the where pattern. The query is the exact same as before, with only one change. We eliminate the first select and only use where and the second select. This is possible with the additional parameter for where that specifies the labeled step D. Both solutions are semantically equivalent. It's just a matter of which syntax seems more readable to you. Projecting traversals are one of our most important tools in our Gremlin toolbox. It gives you the ability to really understand how to walk through your data and pick out that exact piece of data that you're looking for. Now it's your turn to give it a try. Give this next exercise a go and get your hands dirty with projecting traversals.